as said, today I want to talk about KCP, and I want to talk about it specifically in the context of platform engineering and how you can use it to build a platform engineering API. And what that means is, well, I'm going to tell you. So first of all, I should turn this on. Second of all, this is me. I'm a team lead at Kubernetes. You can find me on some socials, and we'll just start from there. So the agenda for today, or for this talk, is I want to talk first about Kubernetes as an API layer, because, well, I think everyone, or mostly everyone in this room, has already worked with the Kubernetes API, and you've probably all used projects that extend the Kubernetes API. So I want to do a little bit of a review of where we are at. Then we're going to talk about some solutions in the ecosystem some challenges that you might encounter when using the Kubernetes API as your control plane. Then we're going to talk about KCP in specific, because I want to basically, tell you about KCP. We're going to talk about some of its characteristics. Then we're going to talk about something that I call the API marketplace. Basically, there's a consumer and there's a provider for APIs, and how KCP can help with that. And then we're going to wrap up. So let's get started with, I don't think it should be a history lesson, but basically, where does Kubernetes stand as an API layer? So this is something that I think most of you have encountered before. The Kubernetes API it was primarily built to, support container orchestration, right? But over the years, and I'm not sure if anyone in the room still remembers third-party resources, that's been quite a while. But the CRDs have basically allowed us to extend a very specific pattern of the Kubernetes API, and that's the Kubernetes resource model. And this is like a technical breakdown of how a resource in Kubernetes would look like, how an endpoint that you request something from with a HTTP REST pattern. But this is a very expressive pattern that has, served well in container orchestration, but with CRDs, we have extended this over the years quite a bit. And if we just look at, this is just a very small view from the CNCF landscape, but a lot of projects have built on the Kubernetes API and have extended it in one form or another. Some of them have done so to improve the container orchestration part. So you can see projects like Rook on here, or Kubeflow. Basically, they use the container orchestration of Kubernetes to provide a specific service. But some of them, they don't really care about container orchestration at all. And one of them would be Crossplane. Another one kind of would be Caverno. Caverno also doesn't do container orchestration per se. It's a policy layer. But the point here is that the Kubernetes API's extensibility has proven to be quite awesome, and it has basically produced a lot of tools that use the Kubernetes API as a control plane while not really caring about the container orchestration aspect. So in a way, Kubernetes API layer, the Kubernetes resource model, it has moved past container orchestration a little bit, because we're using it for so much more these days. And I like to ask, because I get very mixed results from the audience, but do you like working with the Kubernetes API? Maybe show of hands, do you enjoy working with it? Is it I see some. But overall, I would say it's a pretty solid API layer. It's something that has developed over the past 10 years. There's a lot of things built into it: authentication, authorization, admission control. We now have, lately we have admission policies written in CL. I'm not sure how to say it. But the Kubernetes API is a pretty advanced kind of framework to provide declarative APIs. And these don't have to be related to container orchestration. As you can see from the projects that we just saw, not all of them are doing that. Now, the thing is, with the advent of using the Kubernetes API as a control plane, there have been some challenges, I believe. So you all know that, a CRD is cluster scoped. That means once someone installs a CRD, no one else can install the same API type. There's going to be a clash. In addition, not all of these projects really need the container orchestration part. So if you want to just use the Kubernetes API is a control plane for APIs, but you maybe don't care about container orchestration, then maybe you don't need the full thing. There have been some projects that try to make Kubernetes API or Kubernetes clusters more efficient, to make them more lightweight, because you might want to use them at scale, because within a Kubernetes cluster, within a Kubernetes API, you don't have a really good set of security boundaries. So one of the concepts, either this or either this or a similar solution, you can see in several projects these days. Hosted control planes is a term that has been, I think, coined relatively recent, but the concept is around for quite some time. So if you need multiple Kubernetes APIs because you want to separate teams, or you want to give them their own Kubernetes clusters because you need a lot of them, you host them as workloads in Kubernetes. And this is a way to make it more efficient. So you spin up an API server, an etcd, a scheduler, and you put them on a Kubernetes cluster. You don't give them their full dedicated nodes. And through that, you can save some resources because you can, push them around as Kubernetes workloads, dynamically scale them when you need them. But still, this means that you're running a copy of all the components for every control plane, every Kubernetes API that you want to have. And that means that it's still sort of expensive, especially if you want to use the Kubernetes API as a control plane, and you might want to give people their separate API servers or their own Kubernetes clusters just for storing a bit of data, because you want to use it as a control plane and not as a container orchestrator. So what if we took it one step further? And what if instead we partitioned one single API server? So what happens if we create, partitions on a single API server that serve as dedicated or as separate Kubernetes APIs? Because then we can maybe use one data store, we can use the same process to serve a multitude of Kubernetes APIs. And this is what in KCP we're calling a logical cluster. Because in KCP, what we basically do is you share the same API server, you share the same data store, but on top of it, you partition based on the name of the logical cluster. And each logical cluster here, it kind of works the same way. So if we just jump back here, so in this slide, we have 3 Kubernetes APIs we can talk to. In this one, we do as well. And from the outside, they all feel like separate Kubernetes APIs, but they're served by the same project, by the same instance of KCP. So this is the idea, to make Kubernetes APIs even more a commodity, make it rather easy to request them, and basically spin them up in seconds, because you don't need to wait for an etcd to start, you don't need to wait for an API server to start. It's just there because you create a new partition on an existing data store. So now with this kind of central concept, what is KCP in the first place? So KCP is a horizontally scalable control plane for Kubernetes-style APIs. So this takes the Kubernetes resource model, the thing that I talked about earlier, and which many projects have already adopted beyond the container orchestration, and creates kind of a control plane just for APIs. So whatever kind of API you want to offer, as long as it's a declarative API, you can basically put it in the Kubernetes model, and you get a ton of things for free. You don't need to think too much about authentication, authorization. You use Kubernetes Airbag. You use the admission policies that just were added to Kubernetes. Like all these things, they already come from Kubernetes, because there has been 10 years of research and development going into that. So why write your own API if this is basically where you can start off? KCP is a project that started in 2021. Since 2023, like September, October, I think, we got accepted into the CNCF Sandbox. So it's a vendor-neutral project that many different organizations are contributing to build this kind of foundation for building something on top of it. Because it's an API layer. So that means, and this is where platform engineering comes in, well, for platform engineering, you probably want to build more on top of it. you want to maybe build a front end, or maybe you want to do it with Backstage or a similar project. Maybe you want to build a SaaS and you need an API for that. So why not use something like the Kubernetes API to offer that? So yeah, and this is basically where all the different kind of interests meet and build this foundational technology. Sometimes we call it a framework, but I think that can be a bit confusing because it's not a framework, it's something that you start, but it's something that you build on top of. So KCP is more or less a modified Kube API server that you start. Now let's talk about why or what KCP adds on top of the Kubernetes resource model and why it can basically help you. So workspaces are a multi-tenancy unit of isolation in KCP. Because we talked about this earlier, logical clusters, they are their own logical Kubernetes API endpoints. That means these will have dedicated APIs. Like every workspace creates a logical cluster in the background, and the logical cluster will serve different APIs. So you can basically mix and match. So if you own a workspace, you can decide which APIs should be available there without interfering with someone else's APIs. And that's the big difference to what we have today with CRDs being stored well on the cluster scope. So if you share the Kubernetes cluster with someone, well, then you need to agree on a CRD, on an API that you want to have in the cluster. And if you don't share it, well, then you saw earlier, you have to build a completely separate Kubernetes cluster to do so. Obviously, API objects are also not shared across workspaces. If the API definitions are different, the objects are also not going to be shared. And well, because workspaces are units of isolation, you can delegate parts of your KCP instance to someone for administration. So all you can do is basically say, okay, you are now the admin of this workspace, and well, you can do in the workspace whatever you want. I don't care too much. But as a KCP admin, you still have a layer above that you control. So this is basically the ultimate form of delegation and multi-tenancy. And because these are logical clusters, and these are just logical partitions in our data store, workspaces and logical clusters and workspaces, they are incredibly cheap. So basically creating them is done in seconds. In comparison to if you have hosted control planes, you might still wait a few minutes before your data store, your new data store is provisioned, before your pods are all starting up, the usual. So if you create 1,000 Kubernetes control planes, because you have, 1,000 projects, 1,000 teams, well, in KCP, it's done in seconds. In hosted control planes, it'll take probably quite a few minutes and quite a few resources. So this is the scalability aspect of it. Now, workspaces have one more, they have many behaviors, but this one is an interesting one that I want to show you. Workspaces can be put into each other. So you can stack them and you can create this workspace tree. So this means that you're not stuck with, I can create a layer of workspaces, for example, with namespaces, but then I'm done. No, you can create your organizational hierarchy the way that you want. And you can stack them or nest them pretty deeply. So that's basically the idea. And what you see on here, let me see, what you see on here is the URL to the Kubernetes API. So this is basically where it gets practical. So each of these URLs you see on here, if you talk to them with a Kubernetes client, be it a client Go program or be it kubectl or I haven't tried one of the UIs, but I'm sure they will also work. These look like separate Kubernetes APIs to your clients. And this is basically where the separation starts, because you can talk to a specific workspace and interact with it like it was a normal Kubernetes cluster, a normal Kubernetes API, but you have many of these that you can talk to and that you can switch to depending on what you want to do. And well, because workspaces are organized in this tree, you can also think of them kind of like a file system. So basically the way that you navigate on a typical machine, You switch through directories, you go back and forth. You can do this with kubectl, with a plugin that we have as well. So this is basically kind of like a folder system into which you can put your stuff and then go one level up or down in the hierarchy, switch to something completely else in the hierarchy, you name it. So this is basically what makes it very easy to navigate, because this is not a foreign concept to us. Okay. All right. So let's talk a little bit more about so workspaces, they bring a good level of isolation to the table. They are cheap. But what do you do in these workspaces? Because until now, they are basically empty Kubernetes APIs. So what do you do with them? You can do container orchestration, because deployments, nodes, they all don't exist in there, because we've basically taken that part of the API out, because we don't want KCP to be container orchestration. So what's the alternative? The alternative is, API management. And this is basically what I call the API marketplace, because workspaces and the concepts implemented related to API management, KCP, they enable this consumer and provider pattern that I think in normal Kubernetes you don't have as clearly defined. So in the terms of platform engineering, you usually have, a platform team. The platform team will provide, the platform. So they build out a shared set of features that users or the developers can use. But if you go one step further and you say, okay, there's a platform team that builds the platform, but actually I also have domain experts. I have, database admins, or I have someone running my OpenStack. Then these teams, these experts, they don't want to focus on providing an API. They want to provide databases. They want to provide an OpenStack installation. They want to provide, this would be infrastructure as a service. But basically, these teams, they don't really have an interest in building out an API layer. So why don't we give them a tool that they already know, which is like the Kubernetes resource model, and let them register APIs and handle the rest for them. So platform teams basically can run KCP and provide this as an integration point to the service or infrastructure teams, the domain experts that are actually providing a service in your organization. So let's get started with that. I'm going to walk you through that a bit practically. So first of all, let's talk about the service provider. So let's say I'm a database team, or I'm an infrastructure as a service team, whatever, and I want to provide a service. I want to enable people in my organization to use what I produce. And for that, we start out with API exports. API exports are a Kubernetes resource, or a Kubernetes resource model resource, and they are specific to KCP, and they take the idea of of CRDs and separate something, because CRDs have two things happening at the same time. First, in a CRD, you define your schema. You define how your API should look like. But the second thing that happens when you create a CRD is you make that API rateable within the Kubernetes cluster. So you have definition and registration in the same resource. And what KCP does, it separates these two things. So an API export is basically it includes these schema definitions. It says, hey, I provide an API, and that API, I want to offer. But it does not register this API. So just by creating this API export, you can't actually, interact with any objects of that resource type, because you haven't bound this yet. So we're going to start with that, because as a service provider, I'm interested in offering an API. I'm not necessarily interested in binding it. Now we're going to get into some technical implementation details, which I will try to keep short. But basically, APIs can be used across workspaces. But that, of course, means that you have some of these boundaries that we earlier established between workspaces torn down. So you need to be careful about that. And to make sure that, someone providing a service doesn't need to have access to all workspaces to work through the objects and reconcile them. You can implement a Kubernetes-like controller. It's very, very similar to what you would do with stock Kubernetes, and to talk to something that's a virtual workspace. And the virtual workspace provides a proxied view of the data within KCP, and it filters based on what you have access to. So for the API export, I will just see the resources that that are created from my schema. So basically, if I have a virtual workspace, if I have an API export, and I don't know, I offer pizzas and certificates. I don't know, that's not combination, but bear with me. There are objects in different workspaces. There's one in root org A. There's one in there are a couple of ones in root org B. And I need access to all of them because I need to reconcile them. We're still doing reconciling. This is no different from Kubernetes. And that means I'm going to talk to the API export virtual workspace. I need the right airbag permissions for that. And then I will be able to see all these objects and reconcile them. So this is basically how you provide these services across different workspaces. Rather technical, we're just going to move on from that because the consumer side is also part of the interesting bit here. So I said the API export is just the schema definition. It's not yet the registration with an API. And we can look at this here. So I'm not sure how many of you have seen this before, but when your kubectl or most other clients talk to a Kubernetes cluster, they first do an API discovery. So they look at, okay, which API resources are available, and kubectl here even has a command to look at that. And we can see here that workspaces are actually just an API that is registered. So that means to create a workspace, I create another object of the type workspace. That is basically all there is. And KCP dog foods its own technologies. So what you see here, the workspace that you see here, it comes from an API binding. And this is basically describing the intention, hey, there's an API export, that's the schema definition. I want that API available in my workspace. And this is another one of these things where you can, you can break, no, not break, but because it's intentional, but you can traverse workspace borders. Because this is basically where you start. You say, I want an API export, and that API export is maybe provided by a whole different part of my organization, because, well, that's the consumer and the provider pattern. So I'm referencing an API export not only by its name, but also by the path to its workspace. And this is basically where an API binding starts. And this is the second part of the known CID thing. It's the intent to have this API available. And yeah, KCP does the same thing for its own APIs. So the workspace API, it's only available because each workspace is bootstrapped with this API binding. So there's nothing special in what KCP does for itself, basically. And yeah, this is basically something that comes out of that, right? So because I can consume API exports from different workspaces, I can do a mix and match of APIs. So I don't need to say, okay, I don't know, this cluster only has a database service, it doesn't have an OpenStack service or whatever. I can go through the whole, let's say, broadly speaking, service catalog of my KCP instance, which is more imaginary, that doesn't exist as an endpoint, but bear with me. I can go through all the available API exports that I have permission to bind, and I can do a mix and match. And this also means that different teams can offer the same API, and you can make a decision which team's API you want to consume, because, well, I don't know, maybe this department, or maybe you shouldn't really work with that department, or that department provides the service or the API in a slightly different way, whatever your reasons. But you, in your workspace, as an API consumer, you are in charge of that. And just to, I said breaking down the barriers between workspaces. It's true because you traverse them on purpose. And we have extended Kubernetes airbag a little bit to allow for that. So if you want to use an API that is provided by an API export, you need the right permissions. And this also means that the service provider has full control about over who uses the API, because these airbag permissions, they need to exist in the workspace where my API export lives. So that also means that, well, usually service consumers don't even have access to my workspace. All they know is that there's an API export. I am allowed to use that, but usually they can't peek into your workspace and see, oh, what permissions are there, and can I maybe add permissions? Like usually you don't give this kind of access because you separate the two provider and consumer teams. Okay, how are we standing with time? Oh, not too bad. All right, so wrapping up. I think APIs are getting, they are already quite important. Let's not kid ourselves about that, but they're not going to go away. Even if AI is taking over, probably AI wants some nice little neat APIs that it can talk to do things. So APIs are fairly important. And why build it yourself? Because the Kubernetes API has these 10 years of experience, and it has built a lot of engineering power into it. So KCP allows you to use that and focus on the implementation. And this is basically where the project stands, and basically why I think it's interesting to platform engineering. So to wrap it up, it's a global control plane. I haven't mentioned a ton of things here. So for example, you can run KCP in a sharded mode. That means you can span it across the globe, basically. Workspaces are very flexible, so you can build your organization. You can give permissions as people need in your organization. You can create workspaces in the hierarchy as well, as they fit your organization. And because we all already know it, or most of us maybe have written a controller or an operator before, we're all familiar with the tooling. Building something for KCP is incredibly easy based on what we already have. It's a bottoms-up approach. And yeah, because of that, I just want to end with inviting you all. If this sounded interesting to you, the KCP community would be very glad to have you. There's a quick link here to our website where you'll find all kinds of information, our Slack channel, our bi-weekly community meeting, our GitHub repositories, our getting started guides. So thank you very much, and hope to see you soon.
Thank you, Marvin. We have a couple of questions already lined up for you.
Yeah.
I highlighted the first one.
All right, so you wrap KDS API with additional API to achieve segmentation with root access. No, so actually KCP is, its own project. It's based on the Kubernetes API server code, but it's not a wrapper around it. It takes the Kubernetes API server code and extends it. So there isn't really an underlying API that if you had access to that, you would see more. That doesn't really exist because it's its own thing. There isn't a lower layer, except for etcd, but that's also there with Kubernetes.
Any examples using KCP?
So I know that there is a lot of interest. Lots of people talk to us at conferences lately. After I think the other maintainers have advertised this for quite a while. But basically, currently there's no I would say flagship project out there. There are a couple of part of vendors building commercial solutions. But yeah, I don't think they are currently, let's say, open about their adoption of KCP. So yeah.
Okay. Testability. Sorry. This one.
How a resource built on KCP testable? How would you test them on Kubernetes? And there's not really a difference there. So I don't know. Then the same answer as how do you test them on Kubernetes? Or
All right, and this one
would you put your providers next to KCP, or would you prefer to build a bare bones API server? I'm not sure what providers exactly means in this question, but so KCP, same as with Kubernetes, you build controllers, and they provide your API functionality. So if you register an API and someone creates an API object from that, nothing happens, right? You need a controller that does the reconciling. So KCP works the same as the Kubernetes API server. It doesn't have these it doesn't have like a way to plug in controllers. So you write your own controller and run it next to KCP. I think that hopefully is what it meant.
People are getting ideas. That's probably a good thing.
Put in front of regular cadence operators to split their view. No, that's currently not possible. Right now we have a soft fork of the controller runtime library. So if you want to build a controller for KCP, you would basically need to use that fork for now. We are working with upstream to get changes into controller runtime that allows you to reconcile multiple clusters, and that would basically fulfill the need that we would have in KCP to build controllers. But your controllers need slight adaptation, so that's usually the case.
All right, I think. Thank you very much, and let's give a hand for Marvin.
Thank you.